We're continuing with section 15.1 and two more examples. And so the first example is going to cover a property that is called separation. The second example is going to cover a property and is going to allow you to sometimes decide if you want to change the order of integration or iterated integral of the iterated integral. So first one, evaluate this integral. And so let's see, this is going to be basically for x is 0 and 2. So I'm going to write it 0 to 2 and 1 to 3 dx with the 0 and 2, dy with the other one. Integrand is this. So when I'm trying to do the inside integral, I end up with 0 to 2 x squared y dx. Notice y is constant and it multiplies everything else, so it's a constant coefficient. It comes out, and calculation of the integral is going to give you 1/3 of y. Then when you put the 1/3 of y, notice 1/3 is just this integral. I'm changing it's just x squared dx from 0 to 2. And then you put that back in here and you rewrite it as 0 to 3, 1/3 of y dy. This time around, y is not a constant, 1/3 is the constant, and you go from 0 to 3, y dy, it gives you 1/3, y squared divided by 2, 1 to 3, it would be 9 minus 1 divided by 2, which is 8 divided by 2, and that's 4. So it's the entire thing as 32 divided by 3. One thing I want you to notice, that 1/3, this one was integral 0 to 2 of x squared dx. Then you ended up with another 4, which was this integral, and this integral was 4. And so basically what we ended up writing this as integral from 0 to 2 of x squared dx times integral from 1 to 3 of y dy. And why is that? Because x squared times y is a function of x only times a function of y only. In that specific case, and with the rectangular regions, you can separate them as a product of the two integrals. Again, in the other cases, most likely this is not possible. And so you only can do this with extra knowledge, and that extra knowledge here is if the function is function of x only times function of y only. And so you can do it this way. It would have worked if you had the other way of the other iteration of the integrals too, but that's how it works with this iteration. So let's do one example of when it actually changes the situation if you do one way or the other. So let's set both ways for this integral. One way with dx and dy. Dx 0 to 2, 1 to 2. And then the other way is from 1 to 2, 0 to 2, x to the power dy. Oops, sorry. xy dy dx. So when I'm trying to take the inner integral over here, I see that I have x times e to the power x times a constant. So this is going to be an integration by parts. And this one though is not an integration by parts. So I would prefer to do that one first. And so I use this iteration. I prefer this iteration over here on the right to the iteration to the left. So it's not true that it's always completely the same. So if I do the iteration on the right, this is integral x comes out, but not completely because it's still a coefficient of y in the exponential. And so what you get is x e to the power xy divided by the coefficient, which is x from here y equal to 1 to y equal to 2. That is e to the power xy when y is equal to 1 and y is equal to 2. That is e to the power 2x minus e to the power x. So I replace it here and it goes 0 to and that is basically you take this as you take this as dv, and so it would be x e to the power xy divided by y. That's the v, because if e to the power it's the antiderivative of e to the power xy with respect to x, then minus e to the power xy over y dx, and that is x e to the power xy x over y minus e to the power xy over y squared. And then you plug in the values at this point, and you can do 0 to 2, 0 to 2, 0 to 2, so a lot more basically. And for x you plug in 2 and you get 2 e to the power xy over y, I'm sorry, 2y over y, and minus e to the power 2y over y squared, and minus 0, 0 minus 1 over y squared. Okay, so now if you plug that into that integral 0, 1 to 2 of 2 e to the power 2y over y minus e to the power 2y over y squared plus 1 over y squared dy, now you're going to have some issues figuring out this integral. Basically, this is going to basically take a lot of effort to find the integral, and whenever you're at this point you possibly want to think about switching the order. That's how we know when to switch the order. Again, let's summarize. For this evaluation, we pick one iteration over the other because the other iteration was getting to be a more and more complicated integral. And then we ended up with one iteration that was pretty simple, and we ended up with e to the power 4 divided by 2 minus e squared plus 1/2. I click here question 15.1d. Which of these statements are true? And so there are two statements. One of them is a product of two functions of one x only and one y only. The other one is the addition. Which one separates? So now that you're back, it's always the product that separates. So one is the only one that separates into a product of two integral. The other one is it does not separate like that. It's just not working that way, basically.